Start the class. Can anyone respond? Am I audible?
Yes, sir.
Yes, sir.
Thank you. Right. So in this, seen what are the average values, that is IDC and VDC, for both half wave rectifier and full wave rectifier. In today's class, we'll see RMS. In today's class, we'll see what is RMS values. RMS values. When I say values, what does this mean? It can be IRMS or VRMS. Okay, VRMS values. Right. So the formula for S value, the formula to find square root of, okay, square root of area under curve area under the curve of output values. Value means if you are finding current, you put current. If you are finding voltage, you put voltage for this value. Okay, divided by time period of one cycle. The square root is for 4 whole in numerator as well as for denominator. Okay, what does this mean? You read reverse way of this RMS. So if you read reverse way of this RMS, what does it mean? Square, mean, and then take root. If you, because the output of half wave rectifier or full wave rectifier, half wave rectifier looks like this, right? And full wave rectifier looks like this. Output of full wave rectifier looks like this. Correct? This is half wave rectifier output, and this is full wave rectifier output. Okay. Now this is 0 to pi, and from pi to 2 pi there is no output. For full wave rectifier, from 0 to pi we have output. Again from pi to 2 pi we have output, which is replicant of this the same value will be there from pi to 2 pi. Okay, so this is the outputs of half wave rectifiers, half wave rectifier and full wave rectifier. Now if you observe this output, so what is rectifier? Basically, which converts AC. So how does the output of a rectifier looks like? Should look like, correct? It should look like this. But output of half wave rectifier and full wave rectifier, whether this outputs are pure DC, DC, it is not pure DC, right? So it is have component as well as DC component. Means the output of rectifiers, that is half wave rectifier as well as full wave rectifier, both has AC values and DC values, AC component as well as DC component. Right. Okay. So how much component of AC is there? How much component of DC is there? And what is the ripple uh, component that is there? All these things we need to find for both half wave rectifier and full wave rectifier. Much component of DC is there in this half wave rectifier and full wave rectifier in the previous class. Okay, now we'll find how much component of AC component is there in this output. So for that, this is the formula, that is RMS value. So if you observe this waveform, output waveform, we'll see that the values are not constant in the output. That means, say for example, if it is a voltage, you have 0 starting with 0, and you have some voltage here, and you have different voltage here, and you have different voltage here, and you have different voltage here. Means the voltage is not constant with the time, both in half wave rectifier and in full wave rectifier, correct? Because of this, what we'll do is we'll square this values, voltage or current, and we'll take mean of that. We'll which time to which time we are considering, that is from 0 to 2 pi, correct? So that's why it will be, the period of one cycle will be 2 pi, and the output will be from 0 to pi for half wave rectifier, whereas for full wave rectifier it will be from 0 to 2 pi, but we are going to square that value. If you square that, obviously we should take root, so that's why we have taken root. Okay, that's why we have taken, once if you square, we have to take root to normalize the root of that value. So this is what the meaning of this. Okay, right. Now we'll start deriving the RMS value for half wave rectifier and full wave rectifier. Right. So with respect to that formula, with respect to this formula only, we'll move on. Start finding. We'll start finding current first. That is RMS current for half wave rectifier. Okay, RMS current for half wave rectifier. It is called as IRMS. IRMS. So IRMS, that is this. Okay, IRMS is equal to square root, this root, square root 0 to 2 pi, 0 to 2 pi I naught square d theta, I naught square d theta divided by, what is time period? It is 2 pi. Why I naught square? Because squaring of the value, that's why it is square. Okay, now what is I naught? I naught is equal to Im sine theta. I naught is equal to Im sine theta. Substitute this in this equation, you will get IRMS is equal to square root of integral 0 to 2 pi, right? I naught value you substitute Im square theta d theta divided by 2 pi. I'll just replace, continue. If I'm going wrong, please correct me. 1 over 2 pi, okay, integral 0 to pi Im square sine square theta d theta, right? Which is, I'll write this as okay 1 over 2 pi So integral 0 to pi, I will separate now, 0 to pi im square sin square theta d theta plus integral pi to 2 pi, okay, im square sin square theta d theta. So 0 to pi and pi to 2 pi becomes 0 to 2 pi limits. Okay, limits are just separated because we have two parts, right? So now you know well, in case of half wave rectifier, im value from pi to 2 pi will be 0, right? Because we don't have any current from pi to 2 pi. That's why this im value will be 0. Pi to 2 pi im value will be 0, right? So for that reason, this term goes what? 0. So continue. 1 over 2 pi integral 0 to pi im square sin square theta d theta, correct? So because this term is 0, continue. So I can write this as im square, take out this im square out, divided by 2 pi integral 0 to pi sin square theta d theta, correct? So what is sin square theta d theta? So im square by 2 pi integral 0 to pi. What is sin square theta d theta? It is 1 minus cos 2 theta divided by 2, correct? Am I right? You write here why it is, because sin square theta is equal to 1 minus cos 2 theta divided by 2. Okay, now if that is done, so just take out the 2 out. So im square, this 2 you are taking out, so it will be 4 pi, okay, 4 pi. I'll write as, I'll separate this 2, that is integral 0 to pi 1 d theta minus integral 0 to pi cos 2 theta d theta. I've just separated this 2, okay? So what will be next? It will be im square by 4 pi, im square by 4 pi. What is integration of theta? 1 is, it is theta, limits is 0 to pi, integration of d theta is theta. So integration, that is limits are 0 to pi, and then integration of cos 2 theta is sin 2 theta, sin 2 theta divided by 2. Limits are 0 to pi, right? So now if you substitute the limits, it will be, it will be im square by 4 pi, Im square by 4 pi. So it will be pi minus 0 for this, minus minus. So this term will be sine 2 pi by 2 minus sine 0 by 2. Correct? If I am going wrong, please correct me. Okay, so this will be square root of Im square by 4 pi minus 0 minus. So what is sine 2 pi? Sine 2 pi is 0, correct? Sine 2 pi is 0. And what is sine 0? Sine 0 is also 0. Okay, so obviously this term will be Im square by 4 pi into pi, correct? Which is equal to this pi and this pi will get cancelled. Okay, so you will get Im square by 4, which is nothing but Im by 2. This is IRMS, or in other way you can write this as IRMS is equal to 0.5 times Im. Right. So any doubt in this? How to find IRMS? Yes. Any doubt in finding IRMS?
No, sir.
Right. So once if you are familiar in finding one term, the other term will be very easy. That is, if you want to find VRMS, just replace I by V. Just replace I by V. Wherever I is there, just replace I by V. So that becomes VRMS derivation. Clear? So if you just replace I by V, what it happens? It becomes RMS voltage. So I'll just show you 2 lines. Rest you proceed as it is. So just replace I by V. Okay. So this is, instead of current, it will be voltage. Okay. So I, and here it is V naught square. Right? So wherever I is there, just replace by V. So at the end, what you get? At the end you get VRMS is equal to Vm by 2, and which is also, we can also write this as 0.5 times Vm. Clear? Yeah. Did you get what I'm saying? Have you got what I'm saying? How to find RMS and VRMS values of off-wave rectifier?
Yes, sir.
Right. Right. Good. So Next, we'll move on to full wave rectifier, RMS value. RMS value of full wave rectifier. Now you see the formula remains same. Okay, the formula remains same, square of area under curve of output value divided by time period of one cycle. Okay, the formula remains same. So if you want to find current, so 1 second, I'll just write it back. Right. So this remains same, right? This also remains same, right? And this also remains same. This also remains same, right? So now this also remains same. This, now this term won't be 0, correct? This term won't be 0. Why it won't be 0? Because we have output from pi to 2 pi, right? We have output from pi to 2 pi, whereas in half wave rectifier we don't have output from pi to 2 pi. That's why now you write this as Im by 2 theta d theta plus integral 0 to 2 pi Im square sin square theta d theta. So this is what you get. ಮೇಡಮ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಇದ್ದೀನಿ. ಹಲೋ ಮೇಡಮ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಇದ್ದೀನಿ. ಹಾ ಹಾ ನಾನು ಬಂದಿಲ್ಲ, ನಂದು ಲೀವಲ್ಲಿ ಇದ್ದೀನಿ. ಹಾಂ right. So if call comes, my connection goes and comes, right? So here what we can write is, you take out this, because what we have found for half wave rectifier, okay, so I can write this as something like 2 times into 1 over 2 pi into 1 over 2 pi 0 to pi. I'll explain this. 0 to pi, okay, Im square sin square theta d theta. Can I write like this? Because whatever the values which you got here, the same values will be here also. It is replicant. That means it is twice of this component. That's why it is 2. Okay. Are you clear why I have written this into 2? Yes. So because of this, what I can write is, what is the final answer that I got for this value? It is Im by 2, correct? Im by 2 component, that is 1 over 2 pi integration 0 to pi Im square sin square theta d theta. For this value we got Im by 2 into root 2. This root 2 I'll keep it as root 2 itself. So this can I write like Im by root 2. So this is my IRMS value for full wave rectifier. So similarly, if you want to find VRMS, so it will be VRMS is equal to Vm by root 2. Any doubt? Any doubt in this? How I've written this equation
No,
from this
sir.
equation to this equation? Are you clear?
Yes, sir.
Right. Fine. So this is how we are going to find RMS value for half wave rectifier and full wave rectifier. Right. So with this we are done with half wave rectifier and full wave rectifier, uh, DC components and RMS components. Now we'll see what is uh, I can say efficiency of half wave rectifier and efficiency of full wave rectifier. We'll see that. Okay, what is meant by efficiency? How much, what is the capacity of a rectifier to convert from AC to DC, percentage of conversion from AC to DC, that is nothing but efficiency. Okay, uh, uh, it is always derived from power. Okay, so rectification efficiency, right? So it is also denoted by a symbol called eta. Okay, it is denoted by symbol called eta. Always it is represented in percentage eta. Okay, so it is given by a formula, that is percentage of efficiency is equal to P DC, means P output of DC divided by P input AC. So this is into 100 because with respect to percentage, so it is into 100. You know that. So we'll move on with half wave rectifier and full wave rectifier. Okay, so we'll first solve for half wave rectifier, that is P output DC. P DC is equal to, what is P? Power. So how do you represent power? I square R, correct? I square R. So I square DC into RL. This is P output DC, and which is given by what is IDC value of rectifier? It is Im by 2. Sorry, Im by pi. Im by pi. So I can write it as Im square by pi square into RL. So this is PODC. Are you clear how I have written this? Are you clear?
Yes, sir.
right? This is PDC. Similarly, what is the other component which is there here? P input AC. So what is P input AC? PIDC is it not PDC? It is AC. AC is equal to I square RMS, because AC component is nothing but RMS component. Okay, I square RMS into RL. So what is IRMS for off-wave rectifier? For off-wave rectifier, what is RMS value? It is IM by 2, correct? IM by 2 for off-wave rectifier. Now, you can write here, because IDC is equal to IM by pi for off-wave rectifier. So you can write here into, so square, so this becomes 4. So this is RL, you write here, because IRMS is equal to IM by 2. This is for RMS, this is for off-wave rectifier, right? Now once you know this, okay, IM square by 4, okay, now you substitute this and this value and this value in equation 1, that is the formula. So what do you get? So we get percentage of efficiency is equal to, what is PODC? It is IM square by pi square into RL divided by PIAC is IM square by pi square, correct? IM square by, not pi square, it is 4. It is 4 into RL. So what do you get out of this? Into 100. So what do you get out of this? This and this will get cancelled, this and this will get cancelled. So you get 1 over pi square divided by 1 over 4 into 100, right? So upon solving, you get 4 by pi square into 100. So what is the value of this? This will be 0.405 into 100, which is equal to 40.5%. So percentage of efficiency of off-wave rectifier will be 45%. Yes, any doubt in this?
No,
So
sir.
this off-wave rectifier efficiency is 40.5%. Okay, it is very less. Okay, so that's why we went for full wave rectifier. Okay, so we'll see the same procedure for full wave rectifier. Same procedure for full wave rectifier, we'll see. This is for off wave rectifier. Okay, so for full wave rectifier, we'll see. So PODC is equal to I square DC into RL. So what is IDC for full wave rectifier? What is IDC for full wave rectifier? it is 2Im by pi, correct? IDC of full wave rectifier is 2Im by pi, twice of this, right? Twice of this. So I can write 2Im square by pi square into RL, because IDC is equal to 2Im by pi. ಸರ್ ಸರ್ ಹೇಳಿ, ನಮಸ್ಕಾರ. ನಾನಿಲ್ಲ ಇವತ್ತು, ನನಗೆ ಥರ್ಸ್ಡೇ ಫ್ರೈಡೆ ಸ್ಯಾಟರ್ಡೆ ಲೀವ್. ಹಾಂ, ಯಾರಿಗೆ? ಜಿಜೇಶ್. ಹ್ಞೂ ಸರಿ, ಓಕೆ. ರೈಟ್. Now this is PODC, so we need to find P input AC, so which is nothing but I square RMS into RL, right? So what is IRMS for half wave rectifier? IRMS for half wave rectifier is Im by root 2. So Im square by root 2 square nothing but 2 into RL, correct? Because IRMS is equal to 1 over Im by root 2 for full wave rectifier. Okay, so that's why this becomes Im square by 2, because square root 2 square is nothing but 2. Now you know what is PIAC and PIDC, P output DC. Now substitute that 2. Sir, ಹೇಳಿ. No, Thursday, Friday, Saturday I am in leave, no? Second slot means. Is it? I thought that everyone Thursday, Friday, Saturday I thought like leave. Oh, I didn't see the circular. Okay. Right. So now you substitute this PODC and PIAC in equation, the main equation formula. So you get what you get. Percentage of efficiency is equal to divided by PIAC is Im square by 2 into RL. Correct? So PODC and PIAC you are substituting in this equation. You will get this equation. So start solving it. So percentage of efficiency, you will be getting it as, so Im square RL will get cancelled. So you will get 4, this 2 will be multiplied by this 4 divided by pi square, 4 divided by pi square, then into 1 over This is not 2, this is 4. Firing of that nose, that's why this will be 4. Please correct if I'm going wrong. Okay, don't keep quiet. Okay, 4 by pi square 1 over 2. This is the thing that you will get. So final equation will be percentage of efficiency will be 8 by pi square, which is nothing but point into 100 is there everywhere. So this will be 0.812 into 100, which is equal to 81.2%. This is the percentage efficiency of full wave rectifier. Now you can see you can differentiate between half wave rectifier and full wave rectifier efficiency. Half wave rectifier efficiency is 40.5%, whereas full wave rectifier efficiency is 81.2%. Means it is double. Okay, it is double. So we'll stop here and we'll see all other derivations. One or two derivations are there in the next class. Okay, so you take care. You can leave the session.
Thank you, sir.